The universe might be dying sooner than we think. Ever since Edwin Hubble discovered that galaxies were moving away from each other, scientists have known the universe is expanding. And in 1998, that expansion was found to be accelerating, driven by something mysterious: dark energy. The idea caught on quickly. If space keeps expanding faster and faster, then over trillions of years, galaxies will drift apart, stars will burn out, and the universe will fade into a cold, dark void, a slow, quiet ending. The so-called heat death of the universe. But here's the thing. That model assumes dark energy is constant. It behaves the same forever. And now, scientists are beginning to question that idea. In the past few years, astronomers have gathered an avalanche of new data that's forcing them to rethink one of the universe's biggest mysteries. Two massive scientific efforts, the Dark Energy Survey and the Dark Energy Spectroscopic Instrument, have been mapping the structure of the cosmos in unprecedented detail. Together, these projects have charted the positions and distances of hundreds of millions of galaxies. But they weren't just creating a map, they were building a timeline, a way to watch how fast the universe has been expanding at different moments in its history. Here's why that matters. If dark energy really is a cosmological constant, if it's a fixed property of space, then the rate of expansion should follow a very specific curve. It's like tracking a car with the cruise control on. Predictable, steady, smooth. But that's not what we're seeing. The Day and DESI data hint at something more complex. A subtle but significant departure from that curve. A small mismatch. Like a cosmic speedometer starting to behave strangely. The conclusion: dark energy might not be constant after all. It might evolve, it might decay. And if that's true, then the future of the universe looks very, very different. Instead of expanding forever into cold nothingness, we could be on a countdown to collapse. A future where expansion slows, halts, and reverses. Imagine galaxies no longer drifting apart, but drawing closer. Space, not stretching, but shrinking. Gravity regaining its grip on the cosmos. That's the radical shift the data points toward. And some scientists believe they've found a new model that explains it. To explain the strange new behavior hinted at in the data, some physicists are turning to a bold new idea, one that rewrites our understanding of dark energy completely. Instead of being one simple force, dark energy may actually be made of two separate components, one that pushes the universe outward, and one that pulls it back in. The first piece of this puzzle is a hypothetical particle called the axion, something predicted by quantum physics but not yet directly detected. In this model, the universe is filled with an ultralight axion field. This field acts like a temporary, slowly draining battery. It gives the universe a push, causing accelerated expansion. But here's the key: it doesn't last forever. Over time, the energy stored in the axion field decays. That means the outward push it provides, the force we call dark energy, starts to weaken. The second component is a twist on Einstein's famous idea, the cosmological constant. Only here it's negative. That's right. Instead of pushing space apart, a negative cosmological constant pulls everything inward. It's like a spring quietly resisting expansion. Right now, that pull is being overwhelmed by the axion-driven expansion. But once the axion field fades, the spring takes over. This two-part theory doesn't just fit the Day and DESI data, it also predicts a dramatic reversal in the universe's future. A cosmic turnaround. So what does this mean for the future of the universe? This two-part model is right? If dark energy is draining and a negative force is waiting in the wings, then our cosmic story won't end with a whimper, but with a reversal. Astronomers behind this theory estimate that the expansion of the universe could begin slowing down in just 10 billion years. That may sound far away, but it's actually sooner than the time that's already passed since the Big Bang. In cosmic terms, we're more than halfway through the lifespan of the expanding universe. And then comes the collapse. Once expansion halts, the universe will begin to contract. Slowly at first, but accelerating over time, galaxies will start to fall back toward each other. The vast spaces between clusters will shrink. Gravity, once fighting against expansion, will be in control again. As the collapse continues, the energy of the universe will rise. Space will heat up. Cosmic structures will start to break down. Stars, galaxies, even atoms, all drawn together in a final gravitational spiral. Astronomers estimate the end of everything in 33 billion years, from Big Bang to Big Crunch. If this theory holds up, if the universe truly is headed toward a collapse, it changes more than just numbers on a timeline. It changes how we see the cosmos, maybe even how we see ourselves. Because for the past few decades, we've imagined the universe fading quietly into darkness, drifting apart until every galaxy, star, and atom was frozen in time. Slow, quiet death. But this is different. It's dramatic, violent, cyclical. It opens the door to new possibilities, like a universe that restarts again and again. A big crunch followed by another big bang, an eternal rhythm of birth, death, and rebirth. It also connects deeply to some of the biggest unsolved mysteries in physics, like quantum gravity, string theory, and the nature of time itself. But even if we're still far from answers, one thing is clear. The universe is not static. It's alive with change. And we are living in a moment when we can finally begin to see not just where we've come from, but where we might be going. In the end, it's not just about how the universe ends. It's about how much more there is to discover between now and then. The universe may be on a timer, but we still have billions of years left to learn, wonder, and explore. And that's what this channel is all about. If this journey through time and space sparked your curiosity, do me a favor. Like the video, subscribe, and turn on notifications so you don't miss what's coming next. And tell me in the comments. What do you think about the idea of a universe that ends in a big crunch instead of a heat death? Does the idea of a rebirth give you hope? Or something else entirely?